Alright, so we're going to pick up the Lander Classic tutorials with working on the pad this time. So this will be the landing pad that the lander will actually land on. And we're going to then put it together with the surface and the UI we made into a single scene and start writing the main game script that will manage what all these different objects we've been building do. And then we'll be ready to build the lander, and as you'll see at the end of today's tutorial, gameplay as far as level progression, that kind of stuff, is all handled by the main game object. The pad is very simple, the surface are very simple, the lander itself will also be very simple. So let's take a look at it here. I'm going to look at the pad object, and in project settings I'm going to set it to run just the pad. And the pad, what's going to happen is the pad's going to appear in a random spot, and that it's, I say random, it's procedurally generated spot based on the level. And every time the pad drops below a certain point at the bottom of the screen, it's going to reload itself and change to the next level. So this was a way for me to build the pad as a standalone object and then test its ability to reseed every level and be the same every time that it runs. Let's look a little bit about what the object's built out of here. I'm going to turn off the collision layers. So what we have is just some polygon 2D objects, and this is basically the top where the lander will actually land. But you can see you can build some complex stuff here. I've got a rectangle, and then I made another rectangle, duplicated it so we'd have legs, duplicated those so we put them on the other side. None of this has any collision. They're just polygon 2Ds. And then we create collision polygon 2Ds where things have to interact. So I want this to slide down beside the surface, but where this pad is, I want it to hit the surface and know that it can't go any deeper. Because every time we generate a level, the surface is going to be different, and we don't want to do a bunch of math or anything to figure out where that pad can be or how deep it can penetrate into the ground. We just want to create a pad above the surface, have it fall until the collision system, the physics system, says, hey, you're on the ground, and then stop. And we want the legs to be long enough so that they look like they're built onto the ground every time. So to do that, we make two collision shapes. The first one is actually a rectangle, and that's where the ship's going to land. And the second one is a collision shape 2D, and I'm using two different kinds of objects because I had problems with collision polygon 2D penetrating the surface object, which was odd to me. So collision shape 2D, which I've just got set to capsule, that didn't have any problem with penetrating the ground. So whatever was happening there, if it's bug or something I'm doing wrong, doesn't seem to happen with collision capsule. But I left the original collision polygon 2D up here for the ship to collide with, the lander rather. So okay, so that's all this object is a couple of collision hulls and a couple of polygons, and you see, or as you saw when it runs, it initializes its position. When it goes below the bottom of the level, it changes level automatically just for debugging purposes. But let's look at what that looks like in the code. The code for this is really simple. Really simple. Let's see if I can get it all on screen. Actually, let's do this too. You can maximize your code view in Godot. So just a couple of variables, position X, position Y. I don't have these settable in the editor because they initialize and seed based on the level. I reset position true. That is a Boolean value that I'm using because when we get into changing the position of a physics object, it's hard to do that just instantly. So instead, I set a flag, this I reset position, so that as it processes the physics, it says, oh, I have to reset my position. And it does that at a time when it is doing the physics work and it actually has access to the state object. So the ready function just calls initialize. I could do a lot of this ready stuff, or the stuff that I do in the initialize function for right here in ready. But because I want to do this every time a level loads, and I don't want to recreate these objects every time, I've encapsulated that stuff into its own function, called it from ready, and then I call it again in a few other places. When these objects are all created, whether it's the surface or the lander or the pad, I always initialize them with a level of 0 so they know that they're brand new. They even have their own level variable that exists only because I want to run them by themselves or maybe in another game, so I don't want to rely on them having a parent with a level variable. So they'll use it when I'm just debugging, but then when you'll notice like initialize takes level as a parameter, so it'll use the one that it's given as parameter. So if I call it from within itself, it's going to use its own level variable. That would never ever happen. This position would never drop below 740 if there was a surface under it, if it was actually running in a game. This is just kind of a fail-safe variable. Doesn't really mean anything. It uses it in context of running alone, but not in the context of running in a game. So I'm going to show you the main game script in a moment. We'll finish stepping through this. So when we initialize, we're going to seed just like we did with the surface with the level. And then we're going to set the range that the landing pad can appear to between 100 pixels of the left side of the screen and within 100 pixels of the right side of the screen. This is always going to be 1280 by 720. I'm building this for a web game, so one of these tutorials will be to show you how to integrate this into a website. So it's always going to be 1280 by 720. I probably should make these variables so that it could be a different size screen, but I doubt that's going to be necessary because Godot stretches the canvas for you. So even if I always render this at 1280 by 720, if I played it on a bigger screen, I could get it to stretch. So we may just leave those values hard-coded. The position Y is always at 360, so it always appears like in the middle of the screen vertically. We set the linear velocity to 0 because it may have been falling already when it was reinitialized, like in the case of it dropping below the bottom of the screen. It's already got a velocity, so we reset that. And then we set this Boolean flag I reset position true. So I have set my position, or I've reset my position. Integrate forces is called every physics frame, and it's going to check that value to say, hey, have I reset my position? And if it has, it's going to set the state.transform to that position. This is why it's different to use a physics object than to just draw a sprite and directly move it around the screen, because the physics engine is kind of running in its own little world, and you have to interact with it on its terms, kind of. So you can't just set your transform when you want to. You have to set it when you're integrating forces. Any place you have access to this state variable. Okay, and then down here, I've mentioned this before, if it drops below a certain level, it just reinitializes. That is really something that'll only happen when we're running it by itself, not when we're running in the level. So let's take a look at it running in a level. I'm going to switch over to the game itself, and you can see now I've got a single object, lander game, and it contains the pad, the surface, and the UI. And all of these individual objects we've seen run by themselves. So let's run them all together and then look at how the game itself controls them. So I'm going to project settings and just change the active scene, the main scene, and I'm going to play that. And here's our UI, and we press start, and it loads level 1. And you can see the pad is on the surface, so it's colliding correctly. It doesn't sink all the way in because of that second collision hull we put down here, that capsule. The surface is a second object in the scene. So you've got the pad, then the surface. That controls the order in which they draw. So if I drag this, you can see the pad is now in front of the surface. So order matters when you're putting things together in your scene here. You can change that in code too, but dragging it around is just easy. So we have the 3 objects working, and I've also added a few key commands, and I'm going to show you those up here in actually I'll just show them working. So I've got a button I can press, and it's going to automatically win the level. And when we win, it says level 1 complete. None of these lines mean anything yet because there's no lander. You can click next level and you'll get level 2. And I can press my key again, auto-complete the level. Level 2 is complete. And we can see every time I load a level, I get a new surface, and the pad position falls into place, based on how the physics engine reacts. You'll see it slide down. I've also added a keystroke that will automatically fail the level. And that tells me I made it to level 7, so it's telling me I made it to the correct level. And then I can go to the main menu and I can start over, and you see we're back to level 1. Last thing to test is make sure we can pause. Yep, that's working. And make sure we can quit. So everything that we put together in the last tutorials for the UI is working. Everything we built for the surface and the pad is working. And now let's take a look at the code for the main game object. So the script for that is also very simple. Let me see how much of this I can get on screen here. Make sure it's big enough to read. Okay. So here's what we've got. I've defined a few variables. The lander, surface, pad. These variables are going to be the actual objects, the child objects. And in the ready function, I'm assigning those using getNode and selecting them. I think it's just easier to have them assigned to a variable that I can always use than to have to type getNode surface, getNode UI, getNode pad every time. I'm setting the visibility of the pad and the surface objects to false because in the beginning you're only going to see the UI anyway. I don't believe it's necessary to actually set them to false. I may take that out, but because you can't see them anyway, they're behind the main game object. And the last part of the main game function is this process function. And notice we're not in the physics process. We don't care about physics at this point. We're just looking at handling the objects after physics processing has already happened. So we're just in function process. This is my debugging keys. This is just to auto win and auto lose the level. And you can see to do that, all I'm doing is changing the UI state at this point. So there's no lander to really finish the level. There's no lander to crash. So I'm just changing the UI state, and changing the UI state is enough to reset the level, because once the UI state goes to complete or game over, the player is going to go through a loop that takes them through starting a new game or continuing with the next level. So there's nothing else to do besides change the UI state. A lot of this code you'll see is just referencing the UI object. We're going to be talking to the lander object once we build that, but for now we're just talking a lot to the UI. So we check the UI and say, hey, are we doing a new game? And that's set in the UI script. I'm going to show you that every single time someone clicks new game, we're going to set this flag, iNewGame equals true. And then in this script, we know that button's been clicked. This makes it so that I don't have to reference the parent object. I only want to have the parent objects affecting the child objects or checking the status of the child object or something like that. I don't want the child objects reaching back to the parents. So we do change the new game state to false after we've detected it, so that it only runs once. We set the level to 1. We initialize the position of the surface and the pad, and we make them visible because now the game is about to start. When iNewGame is true, that means that we've transitioned from seeing the UI. It's now showing the play field, so we want to show the play objects. If the UI state is next level, which happens when a level has been complete and someone clicks the next level button, we do the same thing we did up here, except we increment the level. Okay, and then the last thing that we do in the main game function is check the UI again to see if we are showing the level complete or the game over screens. And if we are showing the level complete screen, we want to update the text of the level complete screen so that it shows the proper level number. And in order to do that, we have to do something interesting, because we want to take and make a text that actually says level number complete, say level 5 complete. But we need to know that level number. So we've got the level, and it is in the form of an integer. And we need to cast that to a string so that we can add it to other strings, like level is a string, complete is a string. So we use this str function to cast the integer level to a string so we can add it all up. Without that, you'll get an error that says you can't add an integer and a string. And then we do the same thing if we're on UI states.gameOver, except we say we made it to level and then convert that level to a string. There we go. We're giving them a different text, but we're doing the same thing. And we might check that UI state and update more information once we implement the lander. So let's take a quick look again at the running game just to see, make a note of where we're at, and then talk about where we need to go from here. So I'm able to bring up the main screen. Main menu starts automatically. I have credits. I can go back to the main menu. I know that I can quit. I can start a new game, and that'll load level 1, the surface and the pad initialize, and show the gameplay UI. I can complete my level, and it'll tell me the correct level is complete. Level 1 is complete. I can go to the next level. I can complete that. Level 2 is complete. I can complete that. Level 3 is complete. And then I can fail a level, and here it says you made it to level 4, and I can go back to the main menu. From here I can start again, and we're back on level 1, and everything is generating procedurally just fine. So every time it loads level 1, it's the same, the pad's in the same place, the surface is the same, so everything seems to be working. Last thing to test is my pause menu. I hit the escape key, it brings up pause, I can continue, I hit escape again, I can go back to the main menu where I can quit. So time to build the lander and get the last of the logic in the main game function that will handle deciding, have we landed, have we won the game, have we lost the game, so we can replace these temporary lines of code with something more robust and interesting in the next tutorial. Thanks for joining me. Please like, share, and subscribe, and I will see you soon with the tutorial on how to build the lander.